I suppose we could go on and say, well, if you would calculate, if it's just barely acceptable and you were to do a calculation and find that it wasn't acceptable, what would you recommend? And well, a construction project would require you to provide elevations for what purpose? Well, one of the purposes would be for the relative position of all the points within the project, but you may also have to provide a relationship between points within the project area and information outside of it, for instance, matching up sewers and other possible features for which elevation is critical. But more likely it's to do with the relative nature of the points within the project. It seems like it's a fairly tight requirement, but depending on what's being brought in, say for fabrication of some sort or another, that could still be a requirement. If this particular pair of benchmarks is not suitable, then one way of looking at it would be to use one of the benchmarks as a vertical reference, because you would probably have to be relating to things on the outside of the project, and then use the other one but not use its elevation, but its elevation from measurements that are going to provide better connection than what the published elevations would be. So in other words, doing some additional leveling between the two benchmarks to create the elevation of the second benchmark that is known well enough so that the height difference would provide you with the precision that's required. So even a higher level of control than what the special order is. But that wouldn't be too hard to do because it's only over a 300 or 400 meter portion that you would have to be doing it. Obviously, you would have to be using at least the equipment that's recommended for special order, which would be a high precision tilting or automatic level in-bar staves with double scale and all the procedures that are recommended for that, limiting the lengths of sight, balancing them within a certain amount, probably doing 2 or 3 repetitions of the height difference to improve it.
Okay, we do have a question. Actually, I've got 2 questions. Can we touch on SQ6, please? In particular, some good examples. I think the question's actually cut off there.
Well, I can get to SQ6 pretty quickly. So.
And there's also, I think the other one was about SQ3. Okay. Sorry, SQ23.
Okay, let's do 6 first. Have you read Chernovsky's paper from 1993? Is this study guide question is related directly to it?
Yes, he has.
Okay, can you not then answer the question? Okay. Achievable limits on the precision. What's typically the highest precision EDM that's available? Well, today we don't usually look at EDM in isolation because they're so commonly involved with as total stations. If we look at a typical high precision total station, the distances are usually better than a millimeter now, and correspondingly the circle readings and the associated standard deviation of angle measurement is in the order of a few arc seconds. So if we think of that in the context of doing a network adjustment and repeating them, then we get, depending on the geometry, detectability down in the order of a few millimeters. one of the problems with doing the repetition of surveys, particularly if we are doing something that's in 3 dimensions and therefore have to do zenith angles and that sort of thing, that's the problem with refraction. And this is revealed in some of the other references for this section, particularly, I think it was Whitaker's paper, that we can use a robotic total station to a very high precision, but our limit on describing deformation is really the consequence of atmospheric refraction. We have lateral refraction if we are sighting along a surface that is being shone upon and therefore heated up by solar radiation. We definitely have vertical refraction because in most instances we are taking the total station and sighting a reflector. And remembering what I discussed earlier on about measuring zenith angles, that if we have reciprocal simultaneous zenith angles, we can usually remove the effects of vertical refraction. But if we have a sight that's from a total station to a reflector, we don't have that luxury, and so the line of sight is actually very dramatically curved by the effects of vertical refraction. If we look at the mechanism, the most dominant influence is at the total station end of things with the way the curve runs. But still, it's an effect that's very difficult to counteract. So we have achievable limits on the precision, which would be a consequence of the high precision instruments that are being used. The limit on the achievable limit on the accuracy is likely a consequence of the effects of refraction. And not just lateral and vertical refraction, but remember that refraction affects the vector. So not only is there a direction, but also the speed of propagation. So unless we can very with a great deal of fidelity describe the nature of the path, we really don't know what the index of refraction is for EDM measurements, because we sample, say, at one end and at the other end, we really don't know what's happening in between. So again, if we have an example where, say, we're measuring across, say, the outtake from a generating station, and we have a point on the station itself, and then we measure across the water to a point on the other side of the land, and we're measuring the temperatures at each end, that's no indication at all of what the temperature is along the line of sight, especially over water. So we're really taking a pretty healthy guess sometimes as to what the index of refraction is for that measurement. And if we're doing things over different times of the year, particularly, say, at half-yearly intervals, we get the two extremes. The typical one is July and February, or July and January. You can have as much as 40 or 50 degrees difference in the two conditions. And unless we're very careful in making sure that we have accounted for the conditions at that particular campaign, we can have quite a bit of influence as a consequence of refraction. So basically the question, limit on precision is the limit on the instrumentation, or imposed by the instrumentation. Limit on the accuracy is imposed in the fact that we can't evacuate a sphere around the Earth and we have to deal with refraction, both laterally, vertically, and with respect to the speed. So that's study guide question 6. And the other one was 23, was it?
Yeah, although the person who originally asked the question said that it might have already been covered, so you can feel free to disregard.
Yeah, I think that was pretty well covered by my discussion of that one exam question.